Hello, my darlings. Here we are looking at the notes for 3.3 properties of logarithms. And logarithms have some pretty cool properties. This first one, the log of 1 base a has to equal 0. Think about it. This is asking a to what power equals 1? Well, anything to the 0 power equals 1. And we have the log of a base a equals 1. Well, let's think about it. A to what power equals a? Well, a to the first power equals a. Okay. And this is a really cool one that we're going to be using when we get to solving equations. That if we have the log of a to the x base a, well, that would end up canceling and we are just left with the x. So this is going to be really helpful when we're solving equations, as well as this one. So we have a raised to the log of x base a. So the key is this a and this a are the same. So again, that would end up canceling out and we would just be left with x. All right, and, well, this one, I don't know. I think it's kind of silly. It seems obvious to me, but if this is log base a and this is log base a, well, then the stuff inside this has to equal the stuff inside this because it's the same on both sides. All right, so those are really good ones for when we're solving equations. Okay, and here's a neat one called the change of base. Log of a base b is the same as the log of a divided by the log of b. But this could be any base you wanted. So here I just showed it as base 10, or it could be natural log of a over natural log of b. Or you could do the log of a base 2 over the log of b base 2. But these are the two that are important because this allows you to evaluate them on your calculator, because your calculator only has base 10 and base e. So now we know how to evaluate the log of 4 base 7. So we're going to evaluate this using the change of base formula. So I could evaluate this just using the log of 4 divided by the log of 7. Now, depending on your calculator, make sure you close parentheses. Depending on your calculator, if you don't close parentheses after the 4, it doesn't give you the right answer because it puts this log inside of the other log and you get weird answers. So make sure you close parentheses. So I just do the log of 4 divided by the log of 7. And if I did this with natural log, you'd get the same answer. So for b, I just decided to show you can use natural log as well. So the log of 1,460 base 15. I could use the natural log of 1,460 divided by the natural log of 15, and you plug that into your calculator and you get 2.691. Alrighty, now here are some really fun properties. I like to call this letting the genie out of the bottle and putting the genie back into the bottle. These are our properties for expanding and condensing. Okay, so we have 3. The product property, the quotient property, and the power property. So if we're going from left to right, that's called expanding. If we're going from right to left, that's called condensing. All right, and these come from just the basic rules of properties, the basic rules of exponents, excuse me. All right, so if you think about exponents, if we're multiplying with exponents, say I had x squared times x to the 4th, then you add the exponents. So the log of u times v can be expanded to the log of u plus the log of v. When you're looking at exponents, say I had x to the 10th divided by x to the 4th, I would get x to the 6th, because when you're dividing with exponents, you actually subtract. And logs are exponents. That's what they are. Logs equal the exponents. So here, the log of u divided by v is the same as the log of u minus the log of v. And the power property, this one I know doesn't look like it's expanding as much. These ones really look like expanding because it switches from 1 log to 2. But this is still considered expanding. When we're raising a power to a power, say I had like x squared raised to the 3rd power, that would actually equal x to the 6th. So when you're raising a power to a power, you actually multiply the exponents. So here, if I have the log of u raised to the n, well, the log is an exponent and the n is an exponent. So the n can move out front, and we get n times the log of u. So we get this exponent times this exponent. And we can go backwards as well, which, like I said, is called condensing. All right, so example 2, given the log of 2 base c. Notice we don't know what the c is, so we can't use our calculator. So the log of 2 base c is 0.321, and the log of 3 base c is 0.536. We're going to approximate these logarithms using expanding. So the log of 16, well, 16 is 2 to the 4th. So then using the power property, I can move the exponent out front. So I get 4 times the log of 2. And now I know what the log of 2 is, so I'm going to plug that in, and 4 times 0.321 is 1.284. But again, this is only for base c. Whatever c is, we don't know, but this is only for base c. All right, so I'm going to do something similar here. So I have the log of 18. Well, 18 is 2 times 9, but 9 is 3 squared. So looking up here, 2 times 3 squared. Well, multiplication turns into addition. So I have the log of 2 plus. And then again, remember the exponent moves out front. So the 2 is going to move out front. So I have the log of 2 plus 2 times the log of 3. Well, I know the log of 2 and I know the log of 3, so I plug them in. 0.321 plus 2 times 0.536, and just plug that in the calculator and get 1.393. Alrighty, so that's evaluating. Now we get to move to the more fun part. This is the part I like, letting the genie out of the bottle and putting the genie back in the bottle. All right, so we're going to expand these expressions. So we're going to go from the left side to the right side. So I have a fraction. So a fraction turns into subtraction. So I have the log of 2x minus the log of yz. But now this is multiplication and this is multiplication. Multiplication turns into addition. So this becomes the log of 2 plus the log of x. Minus, and this thing becomes the log of y plus the log of z, but it has to be in parentheses because we're subtracting this quantity. So you could either leave it like that, or you could distribute and get log of 2 plus log of x minus log of y minus log of z. Right. So what you can also just kind of figure out then is, look, anything that's in the numerator gets a plus sign, anything that's in the denominator gets a minus sign. All right, so part B. We have the log of a to the 5th cube root b to the 4th. Well, we need to change that so it's an exponent. So remember, a cube root is raising something to the 1/3 power. So I can rewrite this as b to the 4/3. Now, multiplication changes into addition. So I have the log of a to the 5th base 3 plus the log of b to the 4/3 base 3. And then we can use the power property to move the exponents out front. So I get 5 log of a base 3 plus 4/3 log of b base 3. Okay. All right, and C, the last one that we are expanding. Again, I'm going to first rewrite this so that we have exponents. So the square root of x squared is just x. And then this would be the square root of y cubed, which is y to the 3/2. Division or quotient property, the fraction is going to turn into subtraction. So I get the natural log of x minus the natural log of y to the 3/2. Then using the power property, I'm going to move the 3/2 out front. So I get the natural log of x minus 3/2 times the natural log of y. And that's how you expand. So now we're going to put the poor genie back in the bottle. We are now going to condense our expressions, which means if we have a coefficient, it goes back to being an exponent. If we have 2 logs subtracting, it goes back to a single log with division. If we have 2 logs that are being added, it goes back to a single log with multiplication. All right, so here we go. The log of 8 base 5 minus the log of t base 5 plus the log of r base 5. So I'm going to just do the first 2. Subtraction goes back to a single log with division. So I have the log of 8 over t base 5. Then addition turns back into multiplication. So if I multiply 8 over t times r, I get the log of 8r over t base 5. And remember, when you're condensing, two logs turn back into a single log. All right, for B, anytime you have a coefficient, you want to do that first. You want to switch the coefficient back to an exponent before you start condensing the addition or subtraction. So this would become the natural log of x squared minus the natural log of y cubed minus the natural log of z to the 1/3. So I'm going to do these first two. So this would be the natural log of x squared over y cubed minus the natural log of the cube root of z. And subtraction, so again, we get this divided by this. So the cube root of z is going to go into the denominator. So I get the natural log of x squared over y cubed cube root z. And one more. This one tends to confuse people because of these subtraction signs, but notice to use these properties up here, it has to be log plus log or log minus log. There's no log on the a. This is the log of a minus 2. So you can't separate the a minus 1. 2, where did 2 come from? So you can't separate the a and the 1. You can't separate the a and the 8. It's the log of that quantity. So again, the coefficient goes back to being an exponent. So I get the log of a minus 1 cubed base 2 plus the log of a plus 8 to the 4th base 2. And then addition goes back to multiplication. So we get the log of a minus 1 cubed times a plus 8 to the 4th base 2. And we just leave it like that. Ta-da! We are done.